Welcome, Parabolas. Let's go. Take a line L. This line is called the Directrix. And take a point F. This point is called the focus. Then we can define a parabola as the locus of all points equidistant from the focus and directrix. So to make this parabola, what is one point which is clearly equally distant from this point and this line? Well, the point halfway between, and that has a name, it's called the vertex. I've sort of dropped a perpendicular, this dotted line, from F to line L. And then basically I can just kind of pick any point, say, I don't know, that one. And if its distance to the focus and distance to the directrix are the same, then it is a point on the parabola. And we can sort of keep doing this, right? Go all the way out here, distance to focus, distance to directrix, distance to focus, distance to the directrix. I'm just kind of eyeballing this, but these look like pretty good. Okay, and so the parabola itself will be all of these points. Yeah, kind of missed here. Alright. But whatever. Good. So, just to sort of give these definitions, what is the focus? In our case, it's this point F. It's just like point you start with. Point you start with. Then there is a directrix. The directrix is this line L. It's the line you start with. Yeah. And the parabola is, well, here it is, it's wrote, oh no, it's not on the paper. A parabola is the locus of points equidistant from the focus and directrix. Okay, the vertex is, in our case, this point V, and it is just, I don't know, it's just, I'll just say halfway between the focus and the directrix. I guess it's the midpoint of the segment connecting the focus to the directrix, I guess is a better definition. Alright, and this is the axis of symmetry. Alright, so all this is just vocabulary. And again, you can analyze a parabola in different ways. Without coordinates, but with coordinates, perhaps it gets a bit easier. So let's do that now. Alright, here I have a coordinate system that we've established on page 2, and this coordinate system is one in which we've chosen to place the origin of our coordinate system at the vertex of the parabola. This is kind of usually what people do. So again, take the well, maybe I use even a different color for this. Take the directrix here in purple. Take the focus over here. From this, we get the parabola itself. And then we choose a coordinate system which places the origin here at the vertex of the parabola. Okay, so this is 0, 0. And we have decided to use the letter Q to refer to the distance between the focus and the directrix. I guess I want to move this slightly to make it look better. So, yeah, something more like that is good. Okay, cool. Let's see, on the packet I called this point V, this point F, and whatever. Yeah, good. Okay, well, first of all, if this distance here is Q between the vertex and the focus, then it must also be the case that the distance from the vertex to the directrix is Q, because the vertex is halfway in between the focus and directrix. And if this is my origin, then that makes the equation of this directrix x equals negative Q. Okay, how does this parabola open? Well, this is a horizontal parabola. It opens right. The distance from the vertex to the focus is Q. The distance from the vertex to the directrix is Q. The equation of the axis of symmetry is just y equals 0. All right, so now let's just come up with the equation of this parabola using the definition. And there's really only one thing that we can do when coming up with the equation of a geometric object, is to pick an arbitrary point on that geometric object. Okay, so let's pick this arbitrary point z with coordinates x comma y, and if you can tell me what's true about this point, then you'll have told me what's true about every point. And okay, the only thing that I know to be true about this point z is that its distance to the focus is equal to its distance to the directrix. And what is this distance f? So I'll just write this over here. Fz equals, I don't know what we want to call this point, like u or something. Zu, by definition of parabola. Okay, now when it comes to finding this length, you can just use the distance formula or the Pythagorean theorem, which amounts to the same thing. If this is the point x comma y, then that makes this thing y here, and this thing x. And if that's q, then this little bit here is x minus q. Okay, so this length fz is going to be the square root of x minus q squared plus y squared. And zu is going to be, well, let's see, from here to here, that is just x, and this is just q. So this is x plus q. Alright, so this is pretty easy, which is why people usually start with this. I think this picture sort of perfectly explains what's going on. Okay, so if I can solve this equation, and it's pretty easy to do. So square both sides, I get x minus q squared plus y squared equals x squared plus 2qx plus q squared. Make sure this is still in frame. Oh yeah, that's good. So we get x squared minus 2qx plus q squared plus y squared equals x squared plus 2qx plus q squared. The q squareds cancel, the x squareds cancel as well, and what we actually end up with, pretty much just in two lines, is 4qx, y squared equals 4qx. Alright, and that's pretty much it. So this is the equation of a parabola if many things must be true for this to be the correct equation. It's horizontal, which means it sort of goes kind of like this way. Its axis of symmetry is horizontal, I guess you should say. It opens right. That was also built into the picture, that this parabola is opening right. Also, the vertex is at the origin, 0, 0, and also that the focus is q away from the vertex. So this is the equation given those 4 facts. So it's horizontal, that it opens right, that the vertex is at 0, 0, and that the focus is q away from the vertex to the right. Okay, oh, and I should also just say that some textbooks, so don't get confused, some textbooks prefer to write it in x equals form, so you might see like x equals 1 over 4q y squared. Of course, that's kind of like the same thing. All right, but maybe that shows it sort of better, that it's like a sideways parabola or something. Okay, good. Moving on to page 3, we're going to do the same thing over again, but now with the parabola going the other way. So I think we can just do this pretty quickly. So here we go. Again, I will start with my directrix being somewhere down here, and my focus up here. But now, and therefore the parabola itself is going to look something like this. Good. So this is sort of oriented up-down, I guess. And I have chosen, for whatever reason, to establish my coordinate system well. Same as before, I will establish the coordinate system with the origin of my coordinate system at the vertex, but now I've aligned it so that the axis of the parabola is vertical, is along the y-axis. Okay, so that just changes everything slightly. This vertex I'm calling point V, this focus I'm calling point Q, this is all that's on the paper, point F. The distance between the vertex and the focus, I'm still using the little q for that, and I think that's kind of it, right? Yeah. All right, so again, I want to find the equation of this. How can I do it? Well, I pick an arbitrary point, call it z, with coordinates x comma y, and what I know about z, let me use a different color here, what I know about z is that it must be equally distant from the focus and the directrix. Oh, there were some questions. Is this parabola horizontal or vertical? Okay, of course it's vertical. Its axis of symmetry is vertical. It opens up. Distance from the vertex to the focus is q, etc., etc. Okay, what is the equation of this directrix? Well, if this little bit here is q, then this little bit here must also be q. So this is the line y equals negative q. All right, what's the way to derive the equation of this thing? Well, once again, I just need to find these lengths. If this from here to here is y, and from here to here is q, then that makes that vertical red segment, that vertical segment is q plus y. And what's this? You can either use the distance formula, or you can drop a perpendicular sideways and see that that's x. And if that's x, then this little bit here must be y minus q. So if that's y minus q, then what we have is that, again, that fz is equal to whatever this point is, let's call it u. Fz is zu. And what is fz? It's root x squared plus y minus q squared equals, and zu is like y plus q. Okay, so we get x squared plus y minus q squared equals y squared plus 2qy plus q squared, and then that gives me x squared plus y squared minus 2qy plus q squared. And when you cancel all the terms that can be canceled, so we get a boom, 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 then we are left with x squared equals 4qy. And this is the equation of a parabola if it is, like before, it's vertical, it opens up, the vertex is at the origin, and the focus is q away from the vertex. If all of these four things are true, then this is the correct equation. And, okay, you can also write this as y equals 1 over 4q x squared. And sort of already you can see that having adopted this geometric definition of the shape called parabola, the locus of points that are equally distant from the focus and directrix, I have already derived the equation and found that it's a quadratic equation. So this justifies Algebra 1 teachers all over the country using the word parabola to just describe the shape of a quadratic function. What we've seen is that parabolas have a quadratic function equation describing them. And conversely, given any quadratic, you can recover the particular parabola described by that quadratic equation. And so even just to take some, some function like from Algebra 1, f of x equals like 3x squared or some crap like that, what do we have to say about that? Well, based on my new sort of understanding of parabolas, if the relationship between x and y is that y equals 3x squared, then really all we're saying here is that 3 is the 1 over 4q. And if 3 is 1 over 4q, then that means 12q is 1, and q is in fact 1/12. Or maybe you prefer to just think of it as y equals, that's fine, that q is 1/12. Okay, so what is this function f of x equals 3x squared? We never bothered talking about it back when we would graph something like this in Algebra 1, but really you can find, if you look closely, a directrix which is just below the origin with equation y equals negative 1/12 and a tiny little focus right there at 0, 1/12. Okay, cool. Those are the basics, pages 1 through 3. Turn to page 4. Yeah. All right, on page 4, you will find a couple of other pictures. The picture of what happens if the parabola opens left, and here we go. Here is my origin, and basically, if the parabola opens left, then everything is, and this is still the point negative q0, so still I continue to use little q to refer to the distance from the focus to the directrix. So it's going to be exactly the same as the one opening right, but now everything is going to be left. So now we get y squared equals negative 4q x. And this is if it opens left, and on the other hand, if it opens down, then we're getting something like this. Here's my vertex, and again, it's looking pretty bad. I've placed the origin of my coordinate system there. So that's 0, 0. That's 0, negative q. And Now, just like it says in the picture on top of page 4, the equation for this will be x squared equals negative 4qy. Right, so you have some choices. You can, first of all, I'll say that this use of the letter Q is something that I chose to do, but other people use a different letter, P. Our book uses P. So when you see P in our parabola, think Q. That's because we're going to use the letter P for something else later. And then the other thing is, yeah, you can sort of think of this as 4 separate equations. One for if it opens right, one if it opens up, one if it opens left, one if it opens down. This is what I like to do because I like to think of Q as a distance where Q is always positive. But if you prefer to think of Q as like sometimes positive or sometimes negative, then you really just have like 2 equations. Okay, on the rest of page 4, on the top of page 5 are 4 like little problems. So you should just like do those now. Go. Here, there's a tiny focus. Whoa. Alright, pretty quiet here, alone in a room by myself. No one to blame but myself. What is that? Oh yeah. Here, there's this line. Alright, so let's just do this. So here we go. This first problem, you're just told that the focus is at 0, 2. Well, if the focus is at 0, 2, then this is just Q. And okay, if this is, sorry, that means that Q is 2. And if that's true, then that means that my directrix is down here at y equals negative 2. And let's see, the problem just says, give the equation of the parabola and the equation of the directrix. Okay, so what is the equation of the parabola? Well, this is an opening up parabola. So every opening up parabola is in the form x squared equals 4qy. If q here is just 2 and it's opening up, then this is just x squared equals 8y. And that's really all there is to say. Okay, this next problem, here we'll do it like this. What does it look like? Well, now there's a parabola which is opening left, and the focus is here at negative 1/2, 0. Well, if the vertex is the origin and the focus is at negative 1/2, 0, then that means that the directrix must be at x equals 1/2. And it also means that just Q just is 1/2. If it's opening left, then it must be in the form y squared equals negative 4qx. And also Q is 1/2. So this is just y squared equals negative 2x. Boom, boom, boom. Okay. Second to last one over here. Here's a parabola which is opening right, and the directrix, you're meant to just look at the picture and see that this directrix is x equals negative 3/2. And if that's the case, then that means that this distance here between the vertex and the directrix is 3/2. In other words, q is 3/2. And so my focus must be here at 3/2, 0. And this parabola is opening right. So this is a y squared equals 4qx type parabola. Okay, if q is 3/2, then this is just y squared equals 6x. Okay, and finally, last one. I didn't draw yet. Here we go. We have a parabola, and we're given the equation x squared equals negative 2y. So this is opening down, and if this opens down, then it must be in the form, well, x squared equals negative 4q y, and so in this case q is a half. Yeah, there's really nothing to say, much more to say about that. So if q is a half, then I can draw this thing kind of opening down. Well, I know that the focus therefore is at is negative a half away, and the directrix is negative half above. So this is the line y equals a half, and the parabola itself then must look kind of like this. Yeah. Okay, good. Just a little bit more. If you turn to page 5, you'll see, okay, this time we're just going to like really do it. What if the parabola is not centered in such a way that the vertex is at the origin? Well, so here's this kind of picture in which, here, let me get a couple different colors. Here's the origin, or here are the axes. So basically, this sort of makes sense in a world in which you already have some axes that you sort of care about, and now your parabola is sort of somewhere else with respect to those axes. So where is this parabola? Well, let's say that the vertex of this parabola is, instead of at the origin, is somewhere else. It's at this point h comma k. Okay, and here I will draw the directrix is somewhere kind of out here. So this is my directrix. This is as it is in the picture. And my focus is over here. And I would like to continue to use the letter Q to refer to the distance from the vertex to the focus. And so this focus point F must have coordinates then h plus q comma k. All right. And now I will draw in my parabola. Yeah, whatever. Looks decent. Okay, so in this case, what is the equation of this thing? All right, well, all the stuff is exactly the same as it used to be. We just have to reason a little bit more carefully, and things are just a little bit more complicated because there's also this point hk. All right, so again, I'm going to do the exact same thing I did before, which is to pick an arbitrary point, p, or I guess I'm calling it z again, x comma y on this parabola, and if I can find what is true about that point, then I'll know what's true about any point on this thing. Okay, well, let's do it. What is true about this point z? What's true is that the distance to the focus equals the distance to the directrix. And I guess you can sort of still make a kind of similar picture. So here, let's see. The problem is that this point x comma y now, this is in sort of reference to the origin, right? And so if it's in reference to the origin, then what that means is that this little point here must have the same coordinate as x, but its y coordinate is k. So if that's the case, then this length here is y minus k. Okay. And also, yeah. And it also means that this little bit here, that little bit of the triangle, is the difference between x and h plus q. So this is sort of like x minus h plus q. So actually, just like our old proof, you just have to just be a little bit more careful about what x and y mean. Okay, and what is this distance? So this is this z I've been calling this point u. Well, all right. If this, if q is the distance from the focus, from the vertex to the directrix, and this is the point h comma k, then it must mean that this line is like q to the left of that. So instead of x equals h, I'll have that the equation of this directrix must be x equals h minus q. Every point on that line must have that equation. And so what is the length of uz? Well, let's see. I'm going over x and I'm going back by something. I think this is kind of maybe the easy part, right? Because this point has the same y coordinate as y, but its x coordinate is h minus q. So it's like h minus q. Alright, so if I'm here at h minus q, then the difference between point z and u, this distance is just x minus h minus q. I guess that's maybe the way to think about it. Is there maybe a better way to see what that distance is? No, I guess that's the best way. So x minus h plus q. I don't know. Yeah, I guess another way to think about it is if you go all the way over x and then back q, and then also back, or all the way over to x, then back h, and then also back q. That's another way of thinking about it. Alright, but either way, if you're careful, I think this is pretty clear labeling. What you end up with is, well, by the definition of the parabola, fz equals zu, and so we can write the equation of this thing. How? Well, fz, being sort of careful now, is, by the Pythagorean Theorem, it's the square root of this, so this x minus h plus q squared plus y minus k squared. And zu is x minus h minus q, as we found. Alright, so it's kind of ugly, and alright, what we're about to find is that like none of this is really necessary, because